pair is a pair of adjacent angles whose non-common sides are opposite rays. Okay, well, that's a technical way that it's defined. Maybe a better way of saying it is this. Linear pairs will always be angles that are adjacent or side by side. Okay, we talked about adjacent angles before. Okay, they have to have a common side that they share and down the middle here. But angles side by side that when you put them together, they form a line. That's why they call it a linear pair. Okay, so in this picture 1 and 2 here are a linear pair. Those two angles side by side forming this line. And according to the linear pairs theorem, if two angles form a linear pair, well then the sum of their measures is going to be 180. Because after all, this straight line is also what we call a straight angle. Remember when we classified angles, acute, obtuse, right? And there was a straight angle. Straight angles always equal 180 because they're a nice straight line, see? So in this case then, anytime we're dealing with linear pairs, they're going to add up to 180 according to this theorem. Okay, now using that theorem, I'm going to show you some problems here then that I have up on the board. Okay, here's an example where we might utilize that. You can see again we've got our straight line. Here's a ray splitting it up into a couple of angles. So when they're side by side and they form a line, this is a linear pair. So according to that theorem we just talked about, then that means that these two should add up to 180. So all I have to do then is say in this problem, x plus 42 equals 180. Okay, that's a very simple problem. As you can see, if I subtract the 42 over to the other side, it'll reveal what x has to be here. And in this case, that's 138 degrees. So x is 138 on this one. Now, it could get a little more complicated than that, a little bit more difficult. Look at this picture over here. This is also a linear pair. I see the nice straight line. They're side by side there. Okay, so again, I also know then, according to my theorem, that they're going to add up to 180. So this time I'm going to put 8x plus 7, so this angle, plus this one, 4x plus 5, has to equal a grand total of 180. All the way across there is 180. All right, now we got to solve this. You get to utilize those algebra skills that I refreshed you on. You remember, right? I talked about on an equation like this. I want you to recognize that there's multiple x's. They're on the same side of the equation. So that makes it a sheriff-deputy situation. And in the sheriff-deputy situation, remember the two of these then are just going to join forces. Okay, or that's what we call in algebra combining like terms. So if I take a 4x and an 8x, combine them, I get 12x. You could do the same with the 7 and the 5. They're both like terms as well. They both do not have an x on them. So 7 plus 5 is also 12. Just a coincidence on this one that these match. Okay, and then I hope you know what to do from here. We want to continue to add and subtract as long as we can. So I'm going to get rid of this 12. Since it's being added, I'm going to do the opposite. I'm going to subtract the 12 from both sides. And this 12 is currently being multiplied, so to get rid of it, I would have to divide. 12, I think you'll find, goes into 168 14 times. So there's the x value on that one. And if I even wanted to find the measure of the angles, then I could take that x value and plug them back in. So if you plug a 14 into here and take 8 times 14 plus 7, you'll get a grand total on this one of 119 degrees. And on this one, 14 times 4 plus 5 is going to give me 61 degrees on that one. Okay, so you might run into some problems on your homework where you might have to do something as simple as this or a little more complicated with some algebra like this. Now I want to also take a look at the proof. The proof right here on page 66. Okay, that first proof is then a proof of the linear pairs theorem. Okay, so remember on our proof checklist, that means the only thing I cannot use as a reason in this proof is the theorem itself. So I can't use the linear pairs theorem in a proof of the linear pairs theorem. Okay, but if you look, 1 and 2 they say are going to form a linear pair. They're referring back to up here. There's the 1 and 2. Okay, so that's my given. Okay, then on the first blank that I have to fill in here, step 2, they mention that rays BA and BC are opposite rays. And I noticed there's a mistake in the textbook here. It says what property justifies this. It's not a property. Okay, notice they used a special word, a special term, linear pair, in the given. And according to my proofs checklist, if they use any special words, chances are you're going to use that word's definition. And so this is actually the definition of a linear pair right here. Is that by definition, see, remember it back up here? They mentioned that by definition it would have opposite rays. And that's what they're pointing out here. They have opposite rays, see? Okay, in step 3. Now they use definition of a straight angle because they want to kind of point out to the reader there's a straight angle ABC running across here. And the straight angles then, we know by definition, always equal 180 because it's a nice straight line. Okay, but then in step 4, they have the statement here. They want to know the reason. The statement says angle 1 plus angle 2 equals angle ABC. If I look up at the picture, 1 plus 2 equals ABC, the straight angle. Okay, so they're just trying to point out in our picture that 1 and 2, when added together, are going to equal the overall angle ABC. Okay, now, we just talked about, I gave you a refresher, at least at the beginning of class, that told you what this reason would be. And again, they made a mistake in the book. They say property when this one is actually a postulate on this one. But we had the angle addition postulate, if you remember right, from the get-go, that said that any two angles side by side should add up to a grand total of a bigger angle that they form. Okay, but typically it doesn't look like that. You know, typically when we use that angle addition one, it would look like this, where instead of a straight angle, you might have just a normal looking angle, and you'd say 1 plus 2 would equal the overall angle here, whatever it would be called. You know, maybe A, B, C, or something like that. Okay? But that's the angle addition postulate. Very simple idea. We're just simply adding any two angles side by side and creating a bigger new angle, which in this one would be called ABC. Okay, now that kind of sets up our next step because they use the transitive property. Okay, see the ABC back here on step 3? How it equaled 180? And then I got an ABC here. So if you read this, if you actually read this step 4 first and then that one, it flows real nicely because you could say 1 plus 2 equals ABC, and ABC in turn equals 180. So that means 1 plus 2 has to equal 180. Okay, see how they're using the transitive property to do that. Okay, and then finally our last step, remember that definitions work forwards or backwards. Okay, so earlier on a problem I mentioned earlier. I said that if they use the word supplementary, you can use its definition to say they add up to 180. And we're just going to use that definition now backwards. We're going to say, well, we already know they add up to 180. So now I can turn around and use the term supplementary by definition of supplementary. Okay, I already knew they equaled 180 in the previous step. Okay, so definitions work forwards or backwards. So be careful there. It can be a little confusing at times. So there's the proof then of the linear pairs theorem. Okay, the next theorem though on here is the vertical angles theorem. Okay, and again, there's a definition of what vertical angles are. Over here it says vertical angles are the non-adjacent angles formed by two intersecting lines. Okay, so when you have lines cross each other in an X pattern like this, then you'll see it creates angles. They've numbered these 1, 2, 3, and 4. And vertical angles, I don't know who originally came up with the name vertical, but a better name might have been opposite angles, because these are going to be directly opposite from one another at this intersection in the middle. So 4 and 2, the ones directly opposite of each other there, those are vertical angles. And according to this theorem, not only are they vertical, but that means they'll be congruent. They'll match. Okay? 1 and 3. 1 and 3 are another pair of vertical angles. The top and the bottom ones that are opposite each other. And again, they will also be congruent to each other. In this picture that they have here, you can see that 2 and 4 both appear to be acute, and they do look like they're the same measure. 1 and 3 both appear to be obtuse in this one. And again, they do both look like they are the exact same measure. You know, this idea is kind of illustrated by a pair of scissors, for example. I just so happen to have some over here in my kitchen here. So you can see then, as you open and close a pair of scissors, okay, the vertical angles would be the ones directly opposite of each other, here and here, and then up there and down here. And as I change this, you know, as I squeeze these scissors shut, see how that angle got smaller, but so did over here. The handle over here is getting closer together as well. So when you change one angle, the other one automatically is going to change with it, because vertical angles stay the same. Okay, and same goes with these bigger angles here. Okay, they match. You know, if I were to open this up more like this, now that angle just got smaller, but its vertical angle down here also got smaller, and they still match. Okay, so anytime we have lines intersecting like this, then you have vertical angles. In fact, it doesn't just have to be two lines. Give me a sec here to erase my board, and I'll show you an example where we could have more than two lines. Okay, let's say I've got 1, 2, 3 lines like that. And now I've got 1, 2, 3, 4, 5, 6 angles. Okay, now I still have vertical angles though, but you have to think directly opposite. So directly opposite from 1 is 4 over here. So those two are vertical angles, and they're guaranteed to be congruent. Okay, there's more of them, right? 2 is directly opposite of 5. So those two are going to match each other. That's why I marked them both with a double arc. And then see this angle 3, I'm going to mark it with a triple arc. And it's going to be congruent to its direct opposite angle over here, angle 6. So yeah, again, I don't know who came up with the name vertical. I mean, you could say these are vertical, 2 and 5, since they're up and down. But somebody came up with that name vertical angles, when in reality a better name might be opposite angles. While I'm thinking of it too, though, be careful. It does have to be nice straight lines that we're intersecting here. Okay, if this happens, where you have a straight line maybe here, but then this time, as I get down here and intersect here, if I bend this one, now in this picture, yeah, I have 4 angles, but none of these are vertical angles. Okay, because vertical angles are always supposed to be congruent, and they're only created by lines, straight lines that intersect. This was, since this is bent, these are not straight lines intersecting, so there is no guarantee that 2 and 4 would match. Clearly they don't. Look, 2 is less than 4, I can tell just by looking at it. And 3 is less than 1. Okay, so these opposite angles are not vertical angles. Okay, so maybe that's why they came up with that term vertical instead of just saying opposite. All right, so give me a sec here. I'm going to put some problems on my board up here that we might run into when we do vertical angles. All right, here's those problems that involve vertical angles. You can see in this picture, those two are formed by nice straight lines. They're directly opposite. Those are a pair of vertical angles. So this one's a really easy problem. I know according to our theorem that if these are vertical angles, they have to be equal to each other or congruent. So x equals 128. Boom, that one's done. Easy enough. Okay, now on a problem like this one, again, you see I have vertical angles that are directly opposite each other, formed by the nice straight lines. So again, I know that these two are going to be congruent. This and this have to match. Okay, so like I did here, I'm just going to go ahead and set them equal. So I'm going to say 6 plus 3x equals 5x minus 2. Solve for x. Okay, again, I've got an x on each side here, like a sheriff and a bandit on this one. And in a sheriff bandit situation, remember, we want to get rid of the weaker one, so I'm going to subtract the 3x from both sides. That leaves me with 6 equals, this is 2x, and then bring down the minus 2. Okay, focus on the x. You want to get that x by itself. So I need to get rid of both of these 2's. The one that I can get rid of by continuing to add and subtract is this one. Minus 2 we can get rid of by adding 2. But whatever I do to one side now, I've got to do the other like I did up here. So plus 2. 6 plus 2 is 8. That's just 2x. Now to get rid of this 2, it's being multiplied, so I'm going to have to divide. And I find then that x is 4. You could always plug that 4 back in to get the measure of these. And technically it doesn't matter which one we plug into because they should be equal, right? Those are vertical angles. So if you like to add, you might want to put into this one. Or if you don't mind subtracting, you can put it in that one. But anyways, 4. 4 times 3 would be 12. And then 12 plus 6 is 18. So this angle is 18 degrees. And I guarantee this one will be 18 as well. If you don't believe me here, 4 times 5 is 20. 20 minus 2, 18. Okay, so you might run into some problems like that on your homework where you have to work with vertical angles. And just remember that vertical angles are equal. Simple as that. Okay, now I want you to take a look at vertical angles proof, the proof of the vertical angles theorem. Okay, so like we had up here, do you see that 1 and 3, for example, are vertical angles? They're directly opposite from each other up there. So that's what they used here. They say, given that 1 and 3 are vertical, prove that they're actually congruent. All right, so here we go. We were given 1 and 3 are vertical. Okay, second step. The second step, they put angle AEC is 180 degrees and angle DEB is 180 degrees. And they're mentioning that it's just the definition of what it means to be a straight angle. Okay, so if we look back at our picture, AEC and DEB. Okay, there's AEC is that straight line or straight angle. And then DEB is that one that runs that way. Okay. If you're wondering, well, why did they point that out? Okay, you'll see here. It comes into play yet. Okay, look at step 3. They mentioned that they're going to use the angle addition postulate. Okay, angle addition postulate. That's the one, member, that says that any two angles side by side should add up to the bigger angle. Okay, and they looked at their picture here, and to be honest with you, I really don't like what they put there. To be honest with you, I think that they probably should have used, instead of angle addition postulate, when they wrote this step, I would have used the linear pairs theorem. Because the linear pairs theorem is the one that said, hey, those are linear pairs, so they add up to 180. And that's what they're doing here. 1 and 2 are the linear pair up here. See how 1 and 2 are side by side, forming that straight angle they just mentioned? And then the other two they named 2 and 3. 2 and 3 in the picture there are right there, side by side again, forming that linear pair. So to be honest with you here, I just noticed that should not be angle addition postulate. That should actually be the linear pairs theorem. So far, I'm not too happy with this textbook. I've been finding too many mistakes. All right, now, step 4. They have angle 1 plus angle 2 equals angle 2 plus angle 3. Okay, we did a similar trick, I think earlier, if I remember correctly. See how in the previous step, both of these equal 180? Okay, if they both equal 180, then they have to equal each other. So we're saying 1 plus 2 equals 2 plus 3. That's how they got this step. Okay, and if you remember right, the reason for something like that is, in fact, a property, like they say. Do you remember which one? Yeah, it's the transitive property, that if they both equal 180, then they have to equal each other. Remember, the transitive property is like a set of dominoes where one idea knocks down the next. They're like a chain of events. So you could say that if 1 plus 2 equals 180, and then 180 in turn equals 2 plus 3, then you could just say 1 plus 2 equals 2 plus 3. Okay, so transitive property for that one. Okay, then on the next step, I noticed they just have 1 equals 3. You could say that they probably narrowed this down some in the previous step. After all, there's an angle 2 on this side and on that side. See how that angle 2 occurs? It's being added on both sides. So they can then whittle this down a little bit by getting rid of that angle 2. And how do you get rid of an angle 2 that's being added? Yep, you guessed it. On here, we are going to say that we're using the subtraction property. We subtracted that angle 2 off of both sides to get this. Last step is a technical step. If they're equal in measure, that means they're also congruent. And that's what we were supposed to prove, is that they were congruent. So anytime you're converting from equal measures to congruent, or even backwards, from congruent to equal measure, it's always the same definition, because definitions work forwards or backwards. This one is definition of congruent angles. Okay, so there you have the proof of the vertical angles theorem. Okay, and I think that this is going to end my video as well. I think I did enough examples too of proofs that hopefully you're starting to figure out how to fill in the blanks here with the correct reasons. And keep in mind what I reminded you of at the beginning of the lesson. The angle addition postulate is going to be one that comes in handy, even though they had it written here. That's not the correct way you would write the angle addition postulate. The angle addition postulate up here, if we had used it up here, would have been angle 1 plus angle 2 equals angle AEC. They put down that it equals 180. You would actually name the overall angle, in this case, the straight angle. Okay, but keep that in mind when you're doing your proofs of these. And also keep in mind our proofs checklist. You might want to keep that handy. It'll help you then on the proofs.